morning children. In today's class, we are going to learn about interpolation. What do you mean by this word inter? I have some years data given like this: 1990, 1995, 2000, 2005, 2010, 2015. So these we call years. And then population. Population in 1990, say around 90 billions, crores, like that way. Say here some 98, here it is 102, and here it is 109, here some 120, 129, like that. My question is, particularly in a year, say 1996, where 1996 will fall in between 95 and 2000. In this year, what would be the population? That is my question. So this year is falling in any of these values, so we call interpolation. Suppose my question is, what will happen in the year 2030? 2030 falls outside the values given. That is called extrapolation. So this year we are learning interpolation. Interpolation tells me the particular year is falling any of these intervals. It must fall in between the intervals given. Now the value may be in the beginning or the value may fall at the end. Say suppose I want 2013. That falls here. So when it is falling in the beginning, I use forward formula. And when it is falling at the end, I use backward formula. So this is designed by Gregory Newton method. So we find out, and this formula comes under algebraic method. There is yet another method called graphic method. So graphic method, by the word, you just plot the points in the graph. For example, like this. These values, the years I take in x-axis, the population I take in y-axis. Plot the points like this for the years and mark it. As I mark it, it may be in decreasing trend or it may be in increasing trend like this. Something like this way. I want a particular year, say here. Extend the line like this. And this is my answer given by this number. So whichever year I want, extend the line, find out the population for that particular year. So graphic method is a simple idea. All of us know how to plot x and y values. So let us plot x and y values. The diagram may go like this, increasing or decreasing according to the question. I want a particular year, 1996. Under 1996, extend the line like this. The corresponding y value gives me population for that particular year. So I can find in the graph any year that I want. They have given only 2000, 2005 like that. I can find out 2001, 2002, any year that is falling from 1990 to 2015. So graphic is an easy method. Now to give out accurately, we may also go with algebraic method. This method we have Gregory Newton, the first person to give forward formula when the year is falling in the beginning. Backward formula when the year is falling at the end or from the end. Now, yet another formula I write, Lagrange's. The most interesting and adaptive formula I will say, because in Lagrange's, the values need not be regular. Gregory Newton, the values should be regular, 90, 95, 2000. See how do they go? 5, 5 I increase. 10, 10 I have to increase. 20, 20. So regular interval will come. Then I can use Gregory Newton. But in practical life, regular interval is not possible. Many times we may have values like this, 1, 4, 7, 11. They are not regular. Here 3 increasing, here 3, but suddenly 4 increasing. In that case, I can use Lagrange's formula. So this particular exercise, we are going to learn how we are going to apply these methods. Exercise 5.2, question number 3. Using Newton's forward formula, find the cubic polynomial. They have given x and f of x values. Take f of x as y. So instead of f of x, I can call that as y. Find out del y, del square y. Remember, we have done this in the previous exercise. How to find out del y? The difference. 10 minus 1, 9. 1 minus 2, minus 1. 2 minus 1, 1. Then find out del square y. Again subtract. 9 minus of minus 1 is plus 1. So 9 plus 1, 10. Minus 1, minus 1. I get minus 2. One more thing. Del cube y. That is 10 plus 2. That is 12. So till I get one number, I have to keep proceeding. Now this is the Gregory Newton's forward formula. And I can call Newton Gregory or Gregory Newton forward formula. In the forward formula, see what all we need. Y naught, del y naught, like that. When I read the tabular column, x values, I take x naught, x1, x2, x3. So this value I call y naught. This value I call del y naught. This value we call del square y naught. And this is del cube y naught. Let us box it around for us to remember. We cross put a box. This value y naught, del square y naught, del cube y naught, which I can substitute. What else should I know? N. What is n in this question? The Gregory Newton's formula here. Check what we have written. X is equal to x naught plus nh. So what is x? Minus x naught divided by h equals to n. In this question, the cubic polynomial is asked. X is x only minus x naught is the first value here, that is 0, divided by h tells me the spacing. How do they increase? 0, 1, 2, 3. 1, 1 it is increasing. So h is equal to 1 equals to n, or I get n equal to x. X by 1 is x only. So in the formula, wherever n is coming, put x. Wherever del y naught, del square y naught are coming, from the table I have to substitute. So this table we call forward difference table. So from the forward difference table, let us substitute. Y equals to, what is y naught? From here 1. N is x. 1 factorial meaning 1. Del y naught is 1. N is x. X minus 1. 2 factorial is 1 into 2. Del square y naught is minus 2. N is x. X minus 1. X minus 2 divided by 3 factorial meaning 1 into 2 into 3. Del cube y naught is 12. And there is nothing else, so I stop the answer. And so on we have put. Depending on the table, I have to write the next terms. Table terminates with del cube y naught, so I will stop with this number. Simplify, and this is my expected answer. Y equal to 1 plus x. Here this 2 and 2 will get cancelled. Minus x into x. Minus x square minus x into minus 1 plus x. Here I can cancel 3, 4 times, 2, 2 times. Multiply this. X into x, x square minus 2x minus x plus 2. This 2 let me combine here. Simplifying this answer. 1 plus x minus x square plus x. 2x into x square. 2x into 2x. 2x into minus x. 2x into 2. Simplify this answer. Y equal to. First let me write x cube term. 2x cube. X square term. Minus x square, minus 4x square, minus 2x square. Together, minus 7x square. All the x together. X plus x, 2x. 2x plus 4x, 6x. All the numbers together, only one number is here, plus 1. So, from the forward difference table, identify what is y naught, del square y naught, del cube y naught, just by boxing like this. And we know this important formula, x is equal to x naught plus nh as written in Gregory Newton's formula. From here, x naught tells me the very first value. N is how many values are given, or I am finding n there. H tells me the spacing. 1, 2, 3. 1, 1 only it is increasing. So, H is equal to 1. Substituting. What is n we find out. So, n as I get, put it in the formula. Y naught, del square y naught, del cube y naught. As I substitute, factorials we must remember. 1 factorial is 1, 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3. So just simplify and try to find the answer. Question number 4. Using Newton's forward formula, find the population in the year 1955. 1955 falls here. So it is in the beginning interval. I use forward formula. These are x values and these are y values. So call this is x and this is y. Let us create the table. Forward difference table. First I write del y. Subtract 64 minus 58. 58 minus 42. 42 minus 35. Next I have del square y. 6 minus 16. 16 minus 7. Next I find del cube y. Minus 10 minus 9, it is minus 19. We box these values in the forward difference table. Under y, I call this as y naught. 7 I call del y naught. 9 I call del square y naught. And minus 19 I call del cube y naught. The same old formula which we used earlier. Now I must know what is this x. X is the value given in the question. X is equal to 1955. H is equal to, look at the question, 51, 61, 71. How do they increase by 10, 10? So the spacing is 10. H is equal to 10. What is x naught? It is the beginning value, 1951. So I write 1951. Let me substitute in the formula. N is equal to x minus x naught by h. That is 1955 minus 1951 divided by 10, or I get n is equal to 4 by 10, that is 0.4. As we substitute, y is equal to y naught 35. N value 0.4. 1 factorial 1. Del y naught 7. N is 0.4. As I know n, let me find n minus 1, n minus 2. Easy to substitute. So what is n minus 1? 0.4 minus 1. Use calculator and write minus 0.6. What is n minus 2? 0.4 minus 2, that is minus 1.6. So let me substitute here. N is 0.4, n minus 1 minus 0.6. 2 factorial is 1 into 2. Del square y naught is 9 plus n is 0.4, n minus 1 minus 0.6, n minus 2 minus 1.6 divided by 3 factorial is 1 into 2 into 3. Del cube y naught. Del cube y naught is minus 19. As we simplify, 35, 2.8 minus symbol will come. Multiply all this and divide by 2. Again here minus into minus into minus. Minus. Multiply all this, divide by 6. 1 into 2 into 3. Divide by 6. And simplify this answer. Whatever we get represent population of the year 1955. And population they have given in lakhs. So remember to take and write the answer in lakhs. So population of the year 1955 equals to 35.504 lakhs. So remember to write the answer with the units.